Imagine waking up one morning to the news that a massive asteroid is heading straight for Earth. Scientists are scrambling, world leaders are holding emergency meetings, and people everywhere are asking the same question: can we stop it? This isn't just a movie plot. Right now, astronomers are tracking a real asteroid, known as Asteroid 2032, that is moving dangerously close to Earth. While the chances of impact are still being studied, its sheer size and speed mean that if it were to collide with our planet, the consequences could be devastating. To put things into perspective, Asteroid 2032 is estimated to be nearly 400 meters wide. That's more than 4 football fields placed end to end. If it struck a major city, it would release energy equivalent to thousands of nuclear bombs, instantly wiping out millions of people and reshaping the planet's surface. But here's the good news: we have the technology to stop it. Scientists have developed several potential ways to deflect an asteroid. But will they work? And are we acting fast enough? In this video, we'll break down everything we know about Asteroid 2032, the real dangers of an asteroid impact, and whether humanity can successfully change the course of a space rocket before it's too late. Asteroids have been colliding with Earth for billions of years, shaping our planet and, at times, causing massive destruction. Today, scientists are closely monitoring one asteroid in particular, Asteroid 2032. This space rock has been classified as a potentially hazardous asteroid, meaning its orbit brings it close enough to Earth that it requires careful observation. Asteroid 2032 is estimated to be nearly 400 meters wide. To put that into perspective, it is larger than the Empire State Building, about 3 times the height of the Statue of Liberty, and roughly the same length as 1,000 school buses lined up in a row. But size is only part of the problem. Asteroid 2032 is moving at an incredible speed of over 40,000 kilometers per hour. That is faster than a bullet fired from a gun. An object traveling at this velocity carries an immense amount of energy, and if it were to collide with Earth, the consequences would be devastating. Scientists use a system called the Torino scale to assess the risk of asteroid impacts. The scale ranges from 0 to 10, with 0 meaning no threat, and 10 meaning a certain and catastrophic impact. Currently, Asteroid 2032 has been given a low probability of impact, but it remains under close observation. The fact that it is classified as a potentially hazardous asteroid means that while an impact is not guaranteed, it cannot be ruled out completely. If Asteroid 2032 were to strike Earth, the effects would depend on where it lands. If it impacted an ocean, it could generate tsunamis over 100 meters high, devastating coastal cities and flooding entire islands. The force of impact could also disrupt ocean currents and alter weather patterns for years. If it struck land, the explosion would be larger than any nuclear detonation in history. The shockwaves alone could flatten cities hundreds of kilometers away. The dust and debris thrown into the atmosphere could block sunlight, leading to significant global temperature drops and potential food shortages. History has shown us what asteroid impacts are capable of. The asteroid that wiped out the dinosaurs was about 10 kilometers wide, but its impact caused a chain reaction that led to mass extinctions and reshaped the planet. While Asteroid 2032 is much smaller, it could still cause major destruction if it were to strike in the wrong place. For now, scientists continue to track its movements, refining their calculations to determine whether it poses a real threat. The big question is whether we have the technology to stop it if necessary. That is what we will explore next. Scientists have been working on various methods to prevent a catastrophic asteroid impact. If an asteroid like 2032 were on a collision course with Earth, humanity would need to act quickly and use advanced technology to alter its trajectory. There are several possible approaches, each with its advantages and challenges. The first and most tested method is the kinetic impactor technique. This involves crashing a spacecraft into the asteroid at high speed, transferring momentum, and changing its course just enough to avoid Earth. NASA successfully tested this concept with the DART Double Asteroid Redirection Test mission, proving that an asteroid's path can be altered through direct impact. However, for a larger asteroid like 2032, multiple impactors might be needed to create a significant change in trajectory. Timing is also critical. This method works best if applied years or even decades before the expected impact. If an asteroid is detected too late for these slow deflection methods, scientists may consider nuclear detonation as a last resort. Contrary to popular belief, the goal would not be to destroy the asteroid, as breaking it into smaller fragments could create multiple impact threats. Instead, a nuclear explosion would be used to push the asteroid off course. By detonating a nuclear device near the asteroid, the heat and radiation would vaporize part of its surface, creating a force that could alter its trajectory. While this method is extremely powerful, it carries risks, including political and ethical concerns about using nuclear weapons in space. Future technologies are also being explored to enhance asteroid deflection. One concept is laser ablation, where high-powered lasers would be directed at the asteroid's surface to heat and vaporize small amounts of material, generating a force that gradually changes its path. Another idea involves solar sails, attaching large reflective materials to the asteroid to use the pressure of sunlight as a slow but continuous force to push it away from Earth. While these deflection technologies are promising, none are fully operational on a large scale. Developing and testing these systems requires significant investment, international cooperation, and advanced engineering. The key to planetary defense is early detection. The sooner an asteroid is identified as a threat, the more options scientists have to prevent an impact. As research continues, these technologies will play a crucial role in ensuring that Earth is prepared for any potential asteroid collision in the future. If we ignore the threat of asteroids, we risk repeating history.
А что думаешь, может, спутник там уже же падал, они...
The Chelyabinsk meteor that exploded over Russia in 2013 was only 20 meters wide, yet it shattered windows, damaged buildings, and injured 1,500 people. Now imagine an asteroid 20 times that size striking Earth. Scientists have the knowledge to prevent an impact, but research funding is limited, and most asteroid deflection programs lack government support. Without international cooperation, we may not have a plan in place when we need it most. And that's it. Thanks for staying with us once again.